Hi, pre-calc. Just ignore my voice. Not the best, but that's okay. Let's talk about the identity matrix for multiplication. So the word identity hopefully means yourself, right? If you think about your identity, it's who you are. So if we take the identity matrix and multiply it by any matrix, we'll get back that same thing. So let's say A is any matrix. A, we'll say it is a square matrix. And I take that matrix A and I multiply it by I, the identity matrix, I'm going to get back A. And that's the same as if I take the identity matrix and multiply it by matrix A on the other side. Now, what is this identity matrix? It's a specific matrix that looks as follows. If it were a 3 by 3, it would have a 1 in the top left, and then 2 zeros, 0, 1, 0, and then 0, 0, 1. That is the 3 by 3 identity matrix. Notice how we've got 1s along that midline and 0s everywhere else. 2 by 2 identity matrix, 1, 0, 0, 1, 4 by 4, 1 with 3 zeros, 0, 1, 0, 0, 0, 0, 1, 0, and then 3 zeros and a 1, and of course, so on. I'm not going to do more than that. Next thing we're going to talk about is the determinant of a square matrix, and specifically we are going to talk about a 2 by 2 matrix. So let's say matrix A is components A, B, C, and D. The determinant of matrix A is equal to A times D minus B times C. Sometimes we denote this as absolute value of A, so AD minus BC. And this is going to be helpful because if the determinant is not equal to 0, if the determinant is not equal to 0, A inverse exists. Now we're kind of building all these ideas right here. We're going to look a little bit more at them in 7.3, but each of these pieces, the identity matrix, the determinant of a matrix, will come into play when we look at our solving equations in 7.3. Which brings us then to the inverse of a square matrix. So if I take some matrix A and I multiply it by its inverse, they cancel each other out just like inverses do all along, and we are left with the identity matrix. And we can say the same by taking A inverse times A. So that means if we want the identity matrix, which is something we will want, we need to be able to find the inverse of a matrix. So again, let's let A be the matrix with pieces A, B, C, and D. Also, we are only going to deal with 2 by 2 here. If I want to find A inverse, I am going to take 1 over the determinant of A and multiply it by this matrix. I'm going to write it down and then talk about what I did. D, negative B, negative C, and A. Notice what I did is I switched the pieces in this diagonal and I made these two negative. Now remember, the determinant of A is AD minus BC, so we can add that in if we want. And here's how we find an inverse matrix. So I got 2 problems for you. Find the inverse of the matrix A. 2, 4, negative 1, and 3. All right, well, first I need to see, is there an inverse? And in order to determine that, I'm going to find the determinant of A, which, if you recall, is A times D minus B times C. In this case, A, D, B, C. So the determinant of our matrix, 2 times 3 minus 4 times negative 1. 2 times 3 is 6. 4 times negative 1 is a negative 4, but we are subtracting it, so plus 4. And we get 10. The determinant is not 0, which means this has an inverse. How do we find A inverse? Well, we take 1 over that determinant, and we multiply it by the following matrix. Remember, we switch these pieces, so 3 and 2, and we make the other guys negative. -4 and -1. All right, but we're not done, of course. We're going to distribute that 1/10 into every piece. This is our scalar multiplication. So A inverse at the end of the day is 3/10, -4/10, which is really -2/5, -1/10, and then 2/10, which is really 1/5. Now, this might not be that interesting of an answer to you, which is fair, but why is this important? If I took this matrix and this matrix and I multiplied them together, if I did 2, 4, -1, 3 times 3/10, -2/5, -1/10, and 1/5, if I multiplied those together, I am going to get the identity matrix. I promise you. Try it out if you want. I'm not going to right now because, to be honest, my throat kind of hurts. One more problem for you. What about this matrix? Does it have an inverse? If yes, we're asked to find it. So we're going to start again by finding the determinant of A. So I'm taking 5 times 3 minus 1 times 8. 5 times 3 is 15 minus 8. 15 minus 8 is 7. This is not 0, which means yes. Does it have an inverse? Yes. A inverse is going to be equal to 1 over that determinant, 1/7, times, we switch these pieces, 3, 5, and we make the other two negative. And then to finish her off, we just distribute. So A inverse, oh my goodness, is equal to 3/7, -1/7, -8/7, and 5/7. And that, my dear friends, is all I have for you. Finish the other two problems. So that would be 35, 64 to 67. Send me messages if you have questions, and turn this homework in due by midnight tonight, which is 5/12, Wednesday. I'm making this on Tuesday, but you're to turn it in by Wednesday. Have a beautiful day. Sorry about my voice. Have a good one.